Um, oh, okay. So good question. So in uh the link that you where you got the Zoom link, underneath the Zoom link, it says to click here to access my practice test files, and that's where that is. If you don't have it, just email me and I can resend you the link, but it's right there. It's called it's actually right here, like where you can see that where it says the dosage calc practice. It just sends you to my shared OneDrive folder, where you can access the materials there. So if you don't have access to that, just email me and I'll make sure that you do. But you can go on there. When you click on there, you'll pull up everything that I have available. You just have to navigate to the Allegheny folder 130, and then you can download the practice material from there. All right. So for 130, what you guys are responsible for this semester, you're going to have the same type of test, 25 questions. I believe it's a paper test this time around. I don't think it's on Blackboard, but I don't know that definitively. 25 questions. You can miss two. If you miss three or more, you have to remediate, and then take a retest. But I think if you can get through the 110, you know you can get through this one. Just need a little extra practice. You need to make sure you recall your your metric to metric conversions, your household to metric conversions, the things that you prepared for last time. Make sure you know how to convert pounds to kilograms, teaspoons to milliliters, things like that. The You're going to see that urine output and replacement volume question, so we can go over that because that's usually one that students struggle with if that's something that you need to see again. You'll have your oral medications, calculating for tablets, capsules, milliliters, teaspoons sometimes. You'll have your parenteral medications, which is very similar to your liquid oral medications. You're just calculating how many milliliters to administer. You'll do some mixing of insulin, following sliding scale insulin orders. What's new this semester is the IV flow rate. There's a few reconstitution questions, that it's the one where it tells you to choose the strongest concentration. So that's the one that you might run into where you might have some questions. You'll also notice that I've removed it from my review sheet, but you might see that question. And then a two-step problem, which is basically just can you take the patient's weight, convert it from pounds to kilograms, or convert micrograms to milligrams, and then be able to solve using like a multi-step approach. And I'll show you some examples of that. All right, so let me pull up the practice that I have for your class. Give me 1 second. Okay, so 130. There we go. There you are. Okay. And then I'm going to change the share and ready to go. All right. So I'm just going to jump down to the new stuff. And then of course, if there's anything that you want to see again, just let me know and we'll definitely we can look at it again. Um, but I'll go over a couple of the examples similar to what I did yesterday. Um, and that is these flow rate questions. Okay. So this is new. You may have seen a few of these questions when you were doing and studying ATI. But for the most part, they're newer questions for you this semester. And what you need to know is, first of all, you're calculating a flow rate. And a flow rate is just some volume over some time. Usually it's milliliters per hour. Okay. And so that's where we're going to start. We're going to see a nuance to that when we go to drops per minute, but we'll start with milliliters per hour and then go over a couple examples of how to solve when we have a milliliters per hour. So like in this example here, we have an order of 375 milliliters, or the patients receive 370 milliliters of Ringer's lactate over 3 hours. And the question is, what would you set the rate on the infusion pump in milliliters per hour? So to solve this, all you're going to do is take the 375 milliliters over the 3 hours. You're going to reduce that. So 375 over 3, and you're going to get 125 milliliters per hour. So keep it simple. You don't need to overthink it any beyond that. You just want to make sure you're converting your volume, I'm sorry, yeah, your volume over your time. So other examples might be would just get a different volume and a different time. If that time happens to be in minutes, you just need to make sure you can convert minutes to hours. And we'll go over an example of that in just a second. Um, Hold on. I thought I had a example of that. Let me just see here. Okay, no, I didn't have another example. Okay. For this question here, this is an example of where we have a change in time in regards to instead of it being set in hours, it's set in minutes. So we're going to look at that. So it says a patient's receiving a tube feeding of 120 milliliters over 90 minutes. And then we want to know what the flow rate is in milliliters per hour. So again, I'm going to show you this a couple different ways. So I'm going to take my 120 milliliters over 90 minutes. Again, I don't want minutes. I want hours. So what I'm going to do is I'm going to convert minutes to hours. 1 hour is 60 minutes. And then we're just going to calculate that. I think that comes out to 80 mil per hour. But let me just double check. 120 times 60 divided by 90 is 80. Yeah. So that's going to give me 80 mil per hour. Now, some of you probably didn't solve it this way, but I show you this just so you know how to convert minutes to hours if you ever get stuck. If you're someone like me who has multiplied when they meant to divide or divided when they should have multiplied, setting this up or at least knowing how to do it gives you a little bit of an advantage. So you're not guessing, do I multiply in this instance or do I divide? Because a lot of these numbers are going to start to kind of either answer could seem to make sense to you. Okay. Now, some of you also probably did what I typically do is you didn't even do this conversion. You just converted 90 minutes to 1.5 hours. And then by doing so, you just eliminate the need for this. So you just take 120 over 1.5 hours and then 120 divided by 1.5. And guess what? You get the same answer. Now, I also want to make mention that you don't the rate, the 80 milliliters per hour, doesn't have to be equal to whatever the original milliliters is. Sometimes it might be more, sometimes it might be less. The rate is just how fast it's being administered, not necessarily how much is being administered. All right. So once you kind of get an idea of how to calculate for flow rate, the next thing they're going to ask you to be able to do is calculate how long a particular infusion might be running. So again, this is one of those where there's a couple different ways to answer it. But the order says we have 0.9% sodium chloride. We have 500 milliliter IV that's infusing at 125 milliliters per hour. So what we want to figure out is how long is this infusion going to take? When do we need to replace the bag? So the way that I typically start this question is I kind of treat the 500 milliliter IV as my order and the 125 milliliter per hour as my available. And then what I do is I take my order and what I want to do is just convert milliliters to hours. So before I do any math, I just make sure that whatever I have set up, I will be in time. So it could be hours, could be minutes. And then I just look at what my conversion is, 125 milliliters, 1 hour. So this will take us about 4 hours. Or not about, it'll take 4 hours. Now, some of you probably just like reason that in your head, and that's perfectly fine. They do ask you to show your work. Sometimes it's not as easy as what I have set up here, but if you are getting the same answer I'm getting just by doing it in your head, you're doing it right. I'm not here to tell you to do something differently. I'm just letting you know this is the dimensional analysis setup for a question like this, just in case there's ever a time where it's more challenging or more difficult. But if you sat there and you said, okay, 1 hour would be 125 milliliters, 2 hours is 250, or yeah, 250 milliliters, and then 2 times 250 milliliters would be 500, so that would be 4 hours. You're doing it correct. Okay, so there's nothing wrong with doing it that way. It's just I just wanted to show you how I would do it if I was setting it up using math. All right. The next type of infusion type question is going to be the um is going to be doing what's called drop rate. Okay. So with drop rate, we have uh another kind of strategy to follow, and it's going to look like this. In order to calculate drop rate, you need two pieces of information. You need the flow rate, which is usually ml per hour, but it could be ml per minute. You need the drop factor, which is going to be in drops per milliliter and will be given to you. And those two pieces of information will give you the drop rate, which is in drops per minute. If you're on ATI and it mentions microtubing and it wants you to calculate drops per minute, just know that the microtubing drop factor is 60. You won't necessarily need to worry about that for your test next week, but just in case that comes up, if you haven't already seen that on ATI. So you're always going to be given the drop factor. You might have to figure out what the flow rate is, and then you'll figure out what the drop rate is. The other thing I'll mention is drop rates, flow rates can be rounded to the nearest tenth. So you could get like 122.5 milliliters per hour. That's not a problem, at least in the math bubble, the CCAC math bubble. But with drop rate, you can't give somebody a partial drop. So if you get an answer of like 20.3 drops, then the answer is 20. You round to the nearest whole drop. Okay. So in this particular question, it says the tubing is labeled as shown, and you administer the dextrose 5% water IV solution at a rate of 75 milliliters in 25 minutes. So when we look at our label, you can see where it tells us what the drop factor is. Drop factor is 15. So what I'm going to do is I'm going to take my volume over my time. Now, some students like to, just because you get in the habit of doing, when you're doing the other flow rate questions, you get in the habit of converting this to milliliters per hour. If we're ending in minutes, we don't need to convert it to hours. If you convert it to hours, you're gonna have to convert it back to minutes. So you're just you basically are adding an extra step you don't need to add. So if it's already in minutes, leave it in minutes. Multiply by 15. Before you do any math, you can see you're already in the right setup, and then you'll get 45 drops per minute. If that had said, 150 milliliters in 1 hour, then you just want to make sure you convert the hours to minutes before you kind of progress. And I'm going to give you one to practice, um, and then we can just make sure we're all on the same page. I think it's just this one here. So let me bump this down to the next page. Okay, so for this question number 20, where it gives us the 1440 cc's to be infused over 12 hours, even if you've already done this question a couple of times, go ahead and work it out and type into the chat when you get your answer telling me what you would set the infusion pump on for drops per minute. And I'll give you a little bit of time to work on that. Okay, so I'm starting to see some answers. We can't have an answer of 20 milliliters, right? Because we're looking for drops per minute. So it might be 20. Okay. And I think that's what we're looking for. So just make sure you're using the correct units. That's okay. Yeah, I just want to make sure because you should have eliminated mLs. All right. So I think that's the right answer. So I'm going to show you the short way in which I would do this. So first of all, we know that perfect. Thank you. We know that we're looking for drops per minute. So automatically, like in my mind, I sit there and I go, okay, I want to convert this to minutes. So I'm just going to multiply by 60 minutes, which gives me 720 minutes, right? So 12 times 60 is 720. Then when I set this up, so 1440, so CC and ML mean the exact same thing. So there's no difference there. Over the 720 minutes times my drop factor. 1440 over 720 is 2 times 10, and that's where we get the 20 drops per minute. For you guys at Allegheny campus, you won't need to worry too much because the units will be given to you at Boyce and North and South. I believe they are not given like the units that they're looking for, so it's a little bit more important. But the reason I harped on some of you that wrote like 20 ml, if you write that on your test, I don't know if they'll give you that answer. So just make sure your units are correct when you write it down um, on your test. All right, good job, everybody. Okay, um, the next type of like two-step questions are like these questions here. So I gave like two examples. The first example is accounting for the patient's weight for doing a loading dose, and the second one is you have to convert micrograms to milligrams or milligrams to micrograms. So when we do like this type of question here, it tells us that the order is Dilantin, 15 milligrams per kilogram loading dose, followed by 300 milligrams per day as like kind of the maintenance dose. We want to know how many milligrams are we calculating based off of a patient that weighs 176 pounds. So what we're going to do is we need to convert the patient's weight in pounds to kilograms. So that's step one. And then step two is multiply that kilogram body weight by the 15 milligrams per kilogram. Sometimes students get hung up on this 300 milligrams per day. It's only asking you to calculate the loading dose. So we're going to give them a big quantity first, and then we're going to uh, uh, give this as like a maintenance dose here. So what's going to be dependent on the loading dose is how much the patient weighs. So that's why we're doing this. So this extra 300 milligrams per day, you don't need to take that into account. You just need to do the calculation of 176 pounds divided by 2.2. And that will give you, I think it's 80 kilograms, but let me just double check. 176 divided by 2.2. Yeah, 80. And then you're just going to multiply by the loading dose. So in this example, it's 15 milligrams per kilogram. So kilograms cancel out. And then 80 times 15 gives you a loading dose of 1,200 milligrams. So that would be how you would answer that question. Now, let's say they gave you like they said that Dilantin was available in you know, 100 milligrams per milliliter. Then you could calculate how many milliliters if they asked you to do that, but they don't ask you to do that in this particular question. So again, what makes this a two-step question is that you have to convert the patient's weight in pounds to kilograms and then multiply the kilogram body weight by the loading dose. The other example, yes, this is the review packet that's located in um the dosage calc review um shared OneDrive folder that you have the link to. The same like where you got the link for to come onto the Zoom, that link is there as well as the link to the YouTube channel where this is being recorded. So if you just click on that link, navigate to the Allegheny folder, go to 130, and then you'll see all the practice material. And honestly, this should look very similar to the review packet that you received for this semester as well. I'm assuming you received a review packet. I hope you did. You're welcome. Um, and then for this question, it's telling us that the physician has prescribed 500 micrograms of entecavir, um, and that the available is 0.05 per milliliter, and we wanted to just know how many milliliters to administer. So when your order is in micrograms and then your available is in milligrams, we need to convert one or the other to get to in order to add adequate or accurately get an answer for this. So what you can do, and this is good practice for just your conversions, which you've already been practicing. You can just move your decimal point over, or if it's been a little while, you just remember your conversion between milligrams and micrograms. 1 milligram is equivalent to 1,000 micrograms. So that tells you we're dividing by 1,000. So you're going to get 0.5 milligrams as my order. And then I'm just going to divide by the 0.05 milligrams times the 1 ml. So now I just kind of switched into ordered over available, and then we get 10 ml. So those are kind of like the new stuff. And again, I went through this last time as well. So if this is a review for you that were here yesterday, I apologize, but I gave you a warning that I'd probably cover a lot of the same stuff just to make sure um, that anyone that's new sees it. Um, so um, the next step is if there's another question or another question type that you want to see, if you want to review another question type, just either type it into the chat or unmute and let me know. If you want to see any of the previous questions that we went over and you want to see like a variation of that, let me know. That's fine too. If you want to see another flow rate question, but let me know what you want to see. Sure. So, if I'm not mistaken, I've taken it out of here, but the reconstitution questions are just going to give you a let me find it. Hold on one second. I got to pull it up. Just give me 1 second here. I got to find it. I'm just going to add this in after these here. Come on. Sorry, everybody. There we go. Okay. All right. So, um, these are the reconstitution questions that you have seen. Um, and so the biggest thing is, and these are questions that I've been trying to kind of get rid of because they're just poorly put together, but that's okay. So it'll always tell you to choose the strongest concentration. So you just need to make sure you know how to choose the strongest concentration. That's the trick to this. So for this one, it's pretty straightforward. And then you're just going to do 60 over 20, and then your answer is 3 ml. You just need to know how to kind of decipher the information. Where it gets a little bit tricky is this right here, like this Pfizer pen question. So I know you still get asked these types of questions. And what it is they give you like this is what you would see on the label of a reconstitution question. And the trick is you can see where I crossed out all this. We don't care about this. The only thing I care about is what is my concentration. Okay. And then it tells you to choose the strongest concentration. The strongest concentration is whatever's going to have the most, either if it's units or milligrams per ml. And so the most would be 1 million. So you don't even need to worry about the milliliters diluent added. You just need to know to focus on the concentration side of the reconstitution question. So then you're just going to take your 750,000 units divided by a million and then times one, and then you'll get an answer. Now, this one, this is important to know because a lot of students will want to round this incorrectly, but your answer for this would be 0.75 milliliters. And that's your answer. Don't change that to 0.8. Don't round it to 1. The answer is 0.75. And the reason for that is because when you do your rounding rules, you are told that a volume less than 1, you round to the nearest hundredth. So you want both those numbers, 0.75. You're welcome. Thank you for asking that question. I apologize. I got rid of those questions a long time ago, and then but obviously you're probably still going to get asked similar questions. So it's just helpful to know, but they're going to look like this until they stop looking like that. All right. So Morgan number 7. Okay, I think I'm assuming correct. Yeah. So if you get an answer of 0.76, so if the order was 760,000 units divided by a million, then yeah, you don't round. The only time you round is if the number was like 0.767676. It just kept kind of repeating. Then you would round to the nearest hundredth because it's a number less than 1. Good question. Yeah, so I'm assuming that number 7 is going to be. Oh wait, is this the same number 7 you're referring to, Morgan? Okay. Yeah, so the trick to this is, and I highlighted it here, right? You're going to see it's going to ask you how many teaspoons. So you need to make sure that you are calculating for the correct thing. Most students miss this question because they give an answer in milliliters. Okay. So I'm going to show you the two ways to answer this. Well, actually, I'm going to show you the concise way to answer this question. So first of all, here's my order. Here's my available. Okay. 5 mLs is the same thing. So a teaspoon is equal to 5 ml, right? So instead of writing out the 5 ml, what I'm going to do is I'm going to do my order over my available, and then my quantity will just be the 1 teaspoon. And then that gives me an answer of 2 teaspoons. So the trick is don't solve, if you do solve for milliliters, make sure you convert it to teaspoons or convert it to teaspoons before you do anything else, and then you should be okay. Does anyone need a refresher on the fluid replacement question? Oh yeah. So the other way you could do this, Morgan, is if you take the 250 milligrams over the 125 milligrams times the 5 ml, that'll give you 10 ml, and then you just need to convert the 10 ml to teaspoons. So 1 teaspoon is 5 ml, which gives me 2 teaspoons. So that would be the other way to answer that question. Yes. So let me do the fluid replacement, and then we'll bounce over to number 8. So for this one, I'm just going to encourage you to remember the following things. You want to take whatever they actually voided, so their actual output divided by what they expected to void, and then multiply that by the replacement volume. So the actual output will be something that says if urine output for the last 4 hours is, so this is my actual output here. My expected output is where it says for every 125 milliliters of output, and then we replace with 40 milliliters. So the expected output is connected to the replacement volume. Okay. So what we're going to do is Just since I'm going through, if you're already feeling pretty good with this, when you get to number 23, if that's the visceral mepridine question, try it again. Just make sure you calculate the ml of each and then add them together. And but I can still go through and run it over, but you know how to do that question. It's just asking you to do two questions and then add the answers together. But I will come back to that if that still doesn't make sense. So your actual output is the 500 milliliters. Your expected output is 125 milliliters, and then your replacement volume is 40. So if you are following that, the only way that this gets tricky is they might rearrange how they say this. So they might say, if your output for the last 4 hours is 500 milliliters, and for every 125 milliliters of urine output replaced with 40 milliliters of water, what would the fluid replacement volume be? So they might rearrange that to do that. Yes, for your question, if it's a number, if it's a volume greater than one, round to the nearest tenth. So we're going to just take this here, and I believe that ends up being 160 ml as the replacement volume. Okay. Now, some of you have done like different relationships to solve these things. If you're getting the same answer I'm getting, keep doing what you're doing. You're setting it up correctly. So um, don't get hung up on how we're doing it. I find that if you take whatever the actual output is, divide it by the expected output and replace, and then multiply with replacement volume, then you'll get the right answer every single time. The big thing is don't get hung up on that the actual output is always a bigger number. It could be a smaller number. Okay. It could be less than the expected output, but you could still calculate a replacement volume. Like if I told you it was um um like I think it would be 60, like if I told you that they only voided out 62.5 milliliters, that's half of 125 milliliters. So you're just going to replace with 20 milliliter liquid. But I don't think they're going to ask you a question like that. I just like you to pay attention to how they're asking those questions. Um, Number 8, again, you've done this before. The big thing is, do you write your answer as zero point 0.5 or one half? I think when you're writing it, they want you to write it as the half. I've been in the habit of writing this as um, um, like giving both answers, and then you just want to verify with your instructor like how they want you to write something like this. So when you're solving for this, the order is 2.5 milligrams. The available is 5 milligrams. And then your quantity is the one tablet. So this is just going to be half a tablet. So you might want to write it as zero point 0.5 or one half tablet. Just depends on how they want you to write it. Again, in the past, they've wanted you to write 1/2, like the second way I have it written out, but then I don't know. And then that's even changed based off of if it's a paper test versus Blackboard test. So that's why that's there. All right, number 23. Oh, well, I'm assuming like because I know my numbers are skewed here. Oh, you're good. Okay. Yeah. Did that make sense then? I think you were probably, it sounds like you were just getting hung up on the rounding part of it, right? Yeah. Okay, good. Yeah, perfect. Yep. That's the biggest thing. Is there's always those little tweaks, and I'm glad that I can help you out with that. Remember, if it's when you're doing volumes, you can't give them like you don't have a syringe that's going to have an infinite number of decimals after it. So most of your syringes probably only go to the 10th. You do when you get into certain types of or different types of pharmacology, you can measure down to the nano milliliter or whatever it's called, the microliter, and get even more nuanced. But for the most part, you're not doing that, so you don't necessarily need to worry about it too much. So that's why just focusing on um, your rounding rules and then going to the nearest tenth. For numbers for volumes greater than one. If it's a volume less than one, then you can go to the nearest hundred. So like let's say you got an answer for this, and let's say it was like 0.05 ml and then plus 0.15 ml. You would just add those two together and then you would get the 0. I didn't mean for this to happen, but you would get 0.2 ml as your answer. You're just adding the answers to both of those. If you ended up getting an answer of like 0.45 ml, then that's your answer. It's okay to have um a decimal answer like that. But for this question, I think anytime I've seen it, your answer has always been like, 2.3 or 4.7. They'll have different variations, but they just want to make sure you can add them together and then round. Good questions. Very good questions. All right, so we have like another 10 minutes or so. Any other questions? I'm trying to go through some of these a little bit quicker because I know that they're for the most part just kind of review, but even if you can also direct message if you don't want to publicly say, can you do a metric to metric conversion? Oh, yep. Yeah, so when you're marking a cup or a syringe or anything like that, they just want you to mark your answer. So the first thing is what you need to know is that the answer is going to be on the cup, it's going to be on the syringe. So it gives you a little bit of a clue. All right. So for this question here, it says the order is amoxicillin 0.375 grams. The available is 125 milligrams per 5 ml. We want to know how many ml we're going to give and then mark that on the cup. So the first thing I need to do is I need to convert this 0.375 grams to milligrams. So that's 375 milligrams. So I'm going to take my 375 milligrams over 125 milligrams times 5 ml. And that's going to give me an answer of 15 ml. So just make sure you have your answer when you write it out. Okay. And then I'm just going to mark the cup. So there's a couple different ways. Sometimes they want you to shade it in. It does say to circle the correct amount. So I would just circle the 15 ml. I think you're still okay if you put an answer here, kind of like when you dropped the point last semester on Blackboard and you dropped the point like on there. And I think I even told you guys like your answer box basically covers this whole area. So I don't know if it's paper or pens. I don't know if it's paper or Blackboard. I'm not sure. My assumption is that it's paper, but I don't know that definitively. Yeah, so if you're doing it on Blackboard, you just drop the point on the line or on the number. If you're doing this paper, then I would just circle the correct amount like it says. Same thing I would tell you like for like this TubeX question. It's another marking question. So for this one, you have the 75 milligrams over the 50 milligrams per ml. And then 75 divided by 50 is 1.5 ml. And you just want to find that on the syringe. So like I know it says the circle, but like I'm in the habit of like I want to make sure, though it helps if I can draw correctly. Uh, I want to make sure I'm putting my line exactly where I want to make my connection there. So I might draw an arrow or I could just circle it like I'm circle so I know that I'm exactly on the right spot. All right. You'll have to, because remember my numbers are a little bit different than yours. What's 25? Is it this one here? Is 25 the visceral mepridine question? Oh, okay. Here you go. Yeah, so the the question was just, or the strategy is you either convert micrograms to milligrams, which is what I did, or you convert milligrams to micrograms, but you can't you can't calculate an answer when you are in two different units, so that you need to have the same units when you're making that calculation. And then yeah, Maya, are you saying the and I apologize, it might be Mia. I know that I went back and forth with you during AP2, and I know that I'm saying it wrong either way that I'm thinking. So do you want to go do the visceral question? Oh, okay. Yeah, not a problem. Well, first of all, okay, you got it. So, so all I did was I took the 500 micrograms and I converted it to milligrams. So I set this up. You might just move your decimal point, however you convert micrograms to milligrams. I'm assuming you know how to do that. Okay. Then we're going to take the zero point 0.5 milligrams. So that's all that is converting 500 micrograms to milligrams. And then I'm just dividing by the available, the 0.05 times my quantity. And like I said, if I'm like, and I'm not, please don't tell me I'm trying to, please or I apologize if it feels like I'm trying to rush through. I just, if you go back, like if you can rewatch this in the recording, and then you can kind of pause it as you kind of go along, if that's there. And then after I do the visceral mepridine question, if that's still something you want to work through, I'll run through it again. It's not a problem. I don't want you to think I'm trying to discount your question. Yeah, I recorded it. It's already up on YouTube. All right. So for this mepridine question, so we'll just go ahead and do it. Okay. So Mia, since that was the second thing I said, because I knew as soon as I said it, I knew I was saying it wrong. So um we have two medications. We have Vistral, 60 milligrams, and Mepridine, 85 milligrams. So all we're going to do is calculate the ml for this, the ml for this, and then add them together. Okay. And like I said, that's why I was saying, like, you guys know how to do this. So I'm going to take my order of the visceral over my available. I'm going to do the same thing for the mepridine. I have 85 milligrams as my order, 75 milligrams is my available. 60 over 50, I think, is where we're getting the, that's just 1.2. But yeah, makes sense. And then 85 over 75, that's where you get that 1.1333 repeating. And we're just going to round that to 1.1. Okay, because we don't need all those extra numbers. And then I'm just going to add these two together and I'm going to get an answer of 2.3. You're welcome. Mia, I just received your email. Are you talking about the link for the shared OneDrive folder?
Yeah, I yeah, I just couldn't click it at all.
Okay. I'll resend it. I'll reply to your email in just a little bit. I just want to make sure that I had confirmation for that. So yeah, and I never know how they send it to you. If they send it to you as a PDF, it may not show up. But you guys have the same like review packet that I'm going off of. I've probably changed the numbers over the last couple semesters, and that's all that's really different. So okay. So like I said, this is recorded. If you have any additional questions, please feel free to email me. And if you need anything worked through again, or if you need it shown through, or if you need a direct like where is this recorded, just let me know, and I'll get it out to you as soon as possible. But the best thing you can do is just practice the flow rate questions, practice any of the questions that you may have missed last semester. Um, and like I said, I think you got this. You're gonna crush it. But if you have any questions, please reach out to me. And if I don't hear from you, good luck on your test next week.
Thank
Thank
you.
You're welcome.
thank you.
You're welcome.